Okay, guys, welcome GED students and all my math students. So I have another problem from my online class that was stumping some students. So it says describe or show two ways to find the product. And they set their product for you up already, 1/4 times 2/3. So just a reminder, product means the answer when you multiply. Clearly this problem was already telling me to multiply, so it's not giving me any more new information. There's a lot of ways to really, I'm going to do this 3 ways again. Sorry. I want you to see this pictorially before I move on to a multiplication algorithm, because you guys give me all kinds of stuff when we do things pictorially. Or when we do things with an algorithm, I should say, when we do things with a step-by-step process, because my students will just memorize the step-by-step process but not understand it. And so they give me weird answers when they forget their steps or make a mistake and they never even notice. So the first thing I want to do is talk about what this means with a picture. So 1/4 of 2/3. Remember that multiplication is an act of scaling. You can scale things up really large by taking more of them than you have, like 2 times, 3 times, 4 times what you have. But you can also scale things down smaller by taking only a portion of what you have. And that's what's happening here. I want to take 1/4 of 2/3. So I'm going to start with the 2/3. It actually really doesn't matter which number you start with. I just know which one is easier to for me to look at. So, why'd that turn white? So I'm going to draw a box so that I can picture 2/3. I'm going to break it into 3 equal pieces. I totally have the printer in my office, so anytime one of my coworkers prints something, it sounds in the background. So that's that noise. I'm sorry, guys. But here's my box. I broke it into 3 equal pieces. And if I have 2/3, that means I have 2 of those 3 pieces. Now, what I saying to you if I say take 1/4 of that? I'm saying I literally want you now to take what you have, cut it into 4 pieces, and I only want 1. So now I'm going to go the other way on my box so that I can see it. And I'm going to break this into 4 equal pieces. So let me half it and half those halves so that I just broke this into 4 equal strips. Now, I only want 1 of those 4, so I'm going to take a look at the ones I already had shaded black, and 1/4 of them I am going to shade red. So now, can you see what I have left? I have 2 boxes that got involved in both of these things, the 1/4 and the 2/3. The overlap is what I care about here. 2 boxes. 2 boxes out of how many? How many total? Sorry, my 2 got cut off. Out of how many total? Well, let's count how many total now my one whole thing got broken into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 out of 12. Okay, 2 out of 12. And this is a correct answer, but I will remind you, as always with fraction answers, that all final fraction answers should be reduced. So even though this is a correct answer, it is not a finished answer, because all final fraction answers, all the mathematicians in the world got together and decided, since there's so many names for the same value when it comes to fractions, we will all use the reduced version for our final answers, so that we'll be in agreement. And that's because mathematicians like things as simple as possible. So something is reduced when the numerator and the denominator of the fraction have their greatest common factor as 1, or nothing will divide the 2 of them except 1. But 2 and 12, they definitely have a number bigger than 1 that divides them both. The way that I can tell is that they're both even. Can you notice that they're both even? All even numbers are divisible by 2. When you reduce a fraction, what you're doing is you're pulling out the number, you're dividing out the number that they have in common. Notice, it's the same number top and bottom. If it's not the same number top and bottom, you're going to change the relationship between my numerator and my denominator so that I won't get an equivalent fraction. But as long as it's the same number top and bottom, you're really just dividing by 1, because 2 over 2 is just a fancy name for 1. And so that's why we're not changing value. This is just a fancy name for 1. So I'm not really changing my fraction's value, just its appearance, and that's why this is legal. So 2 divided by 2 is 1, and 12 divided by 2 is 6. And I can see that 2 out of 12 is the same as 1 out of 6. And I can show you that in my picture too. So let me pick up a different color. And I can show you that if I put these two squares together, I have 1 out of 6 of these. So 2 squares is 1. There's another 2 squares, 2. Another 2 squares, 3. Another 2 squares, 4. Another 2 squares, 5. Another 2 squares, 6. So another way to look at 2 out of 12 is 1 out of 6. And we can see that pictorially. Okay, great. So I envisioned this multiplication problem with pictures. Now let's look at another way to do it. You can go what I think of as the long way. So you might realize that when multiplying fractions, I hope you know that because this is an act of scaling, I really can just multiply straight across the top and straight across the bottom. It's not like adding and subtracting where I have to have the same kinds of things. Multiplication, since it's scaling, any size denominator and any size numerator can multiply. So 1 times 2 is 2, and 4 times 3 is 12. But just as before, I need to pull out any common factors. And of course, 2 and 12 are both even, so they're both divisible by 2. And I can see there, when I reduce this fraction, I do end up still with 1/6. 1/6. Okay, so this is this is my pictorial method. Now, what did I do here? Here, I multiplied first, so you can multiply your numerator times your numerator and your denominator times your denominator, and then at the end, I reduced. Well, as it turns out, since reducing is just dividing out common factors, and multiplying, and which is the operation that I'm doing, is the inverse of dividing. Let me say that again. Multiplication and division are inverses. It's like doing the same thing forwards and backwards. Multiplying is putting groups together. Dividing is pulling groups apart. But since they're inverses, they're really the same kind of operation, which means that it doesn't matter the order that I go in. I could do my multiplication first. I could do my division first here, and I'm going to get the same answer. So I want to show you that I could actually use what most teachers refer to as cross-reducing. I could reduce before I multiply. So that's a third method. This is my favorite because if you reduce before you multiply, your numbers will get smaller before they get bigger, and so your math will be easier, especially when your fractions are large. On a problem like this, it actually doesn't matter so much if you cross-reduce. But on some other problems, cross-reducing is the only way to go. Like, it would be really junk to multiply them all together before I reduced, because it would take me a long time. But when you cross-reduce, you just look for any number in the numerator with any number in the denominator that have a common factor. And look what I see. 4 and 2 are both even. Now see, 1 is in the numerator, it's up top. 1 is in a denominator, it's on the bottom. As long as 1's on the top and 1's on the bottom, you can pull out any common factors before you even multiply. And so that's what I'll do. Both 2 and 4 are divisible by 2, so I'm going to divide out the 2 they have in common. This is the work I'm doing in my head. I don't usually write it down, but I'll write it down now so you can notice what I'm doing. And I'm going to cross out the number that I currently have and write the answer after I divide. So 2 divided by 2 is 1. Notice I write down the answer, not the 2. And 4 divided by 2 is 2. And so I cross out the old number, and there's my reduced number. Now, if I look here, I'm not going to be able to cross-reduce anymore because I only have 1's on the top, and 1's can never get any smaller. So no matter what I have on the bottom, I'm not going to be able to get any smaller on the top. And so I'm done here. So 1 times 1, I multiply straight across is 1, and 2 times 3 is 6. And I can see that I got the same answer. And in fact, I even did the same work as I did before, except I just flipped the order. I reduced first, and then I multiplied my numerator times my numerator and my denominator times my denominator afterwards. Okay, and so again, because multiplication and division are inverses, you can feel free. The order doesn't matter. You can multiply and then reduce, or you can reduce and then multiply, and you'll get to the same place. So there's 3 different ways to multiply fractions. Great. Tricky, I know, but useful to know all 3 ways, because sometimes one is better than the other. Ask me any questions that you have. Drop them in the comments, shoot me an email, whatever, and I'll be happy to answer them.